So we're 13, 5 to 8. So you could either fill in the first blank with crystals or fill in the second blank with crystalline. Either way, pick one. It's not 2 points if you fill them both in, just pick one. 2 is expands. Extra credit is that it gets higher, it raises. Has to be like higher than normal. Water's the opposite on everything, it's lower than for that extra credit. Number 3 is plasma. Number 4 is nuclear fusion. If you just said fusion, good enough for me. 5 is a supernova. 6 and the extra credit. One of them could be neutron star, the other one's pulsar. Those are interchangeable synonyms, so which one you do where doesn't really matter. 7's a black hole. 8 is conductors. 9 is superconductors. Extra credit, something like it consistently provides a good explanation of the behavior of matter, or it's been tested and observable phenomena consistently agree with its predictions. That's what we're hunting. That would be an extra credit you certainly earned. It's probably not going to be right today. 10, inference fills in either blank, pick one. They said it 2 different ways, so I gave it to you both ways, but inference fills the blank either way on 10 for a single point, regardless of how many blanks you put. Question about the new stuff there, top 10, I'll explain those in more detail once you've got your own paper back and take your own notes.
What was 5?
5 is a supernova.
What is 6?
6 is a neutron star or a pulsar, with the extra credit being available as the other one, because those are 2 words for the same thing. More to 10. Starting on 11, that's our old ones, so it's to explain the behavior of matter. The 3 parts is matter is made of very small particles. The particles are in constant motion, and cohesive forces or attract particles of the same kind. Question about front. Back to 15 is van der Waals forces. Then we're going strongest, medium, and weak, something like that. The who conducted experiments, I misnumbered that. It's again, this says 10, but that should be 19, but 9 and 0 are neighbors on a keyboard, so oopsies. Robert Brown, just Brown would be enough for me. Fluid for 20 is anything that flows. Expand and then contract. 23, there's greater rebound on the collisions and the cohesive forces are less. 25 is vibrate. 30 is convection currents. Example would be like a radiator system that heats anything, like my dorm room. 32 is a bimetallic strip. Example of that would be like a Mr. Kellner room 6 thermostat. 34 is surface tension. 35 evaporates quickly. 36 is attractive forces between different kinds of things. 37, or no, it's not, I'm saying the wrong numbers because it got renumbered this year. Capillary action for 33 occurs, I said if adhesion is greater than cohesion, but you could also go with if it's more attracted to other things than it is to itself. Didn't ask for an example there, it would have been a paintbrush, but that didn't make the cut. 34 goes down. 35 is because the highest KE particles are gone, so the average has to go down. 40, it's going down. 36, it goes down. Last question, why? It's easier for the molecules to escape if you lift the pressure a little bit. Question about scoring, question about back.
What's it out of?
It's out of 37. A truly perfect score, if you got all the extra credit, would be a 41. For next quiz, I gave you one already by email when we were closed, so you have in your possession a 5 to 8B quiz. That's the next quiz for next time I see you, when the weather lets us have school. If you didn't fill that in yet, here's my side notes that would help you fill that in and some explanation of things. So take them if you need them. One doesn't need an explanation. Two, two's an illustration to me that God is smart. So water expands as it freezes. What does that let water do when it becomes ice and it's out in a body of water? Floats. Okay, water, when it expands as it freezes to make ice, becomes less dense and it makes it float. If water did what everything else does, which is become more dense as it freezes, all of that ice would sink. What would happen to all? There would be two bad things that would happen, at least. What would be a bad thing that would happen if ice
Everything
sank?
under the ice would die
Everything under the ice would die. Why?
because it would sink and get crushed.
It would sink and like trap it. So all of that sinking ice would be trapping all that sea life and crush it at the bottom. What else would happen to the ice at the bottom once it got warmer?
I don't know if this is what you're going for, but like the water at the top would like go up higher since it's getting pushed down by the ice.
That's true, but once you get ice, let's say at the bottom of Lake Erie,
It wouldn't melt.
it would melt never. Because what's going to melt the ice is warmth and heat and sunlight and all those things. So if you had ice sinking to the bottom of something deep like Lake Erie, that would never like thaw out again. So I'm saying God is smart. That's not going to get you a point, but that's just what I'm saying. When pressure increases, the freezing point of liquids usually raises because pressure like is pushing down on stuff. Things as they freeze, not water, but other stuff wants to. What do most things do as they freeze? Expand or contract? They contract. So if you are going to put pressure on it, that's going to make it
More dense.
more dense. It's going to help it contract. So instead of freezing at 0, it might freeze at like 10 and be ready to freeze because the pressure would help make it easier to freeze even at warmer temperatures. So generally when pressure goes up, freezing point goes up, but water's the opposite, it goes down. Plasma, some stuff about plasma that might or might not make a quiz or a chapter review or whatever. It makes up a little bit or a lot of the universe.
Like a lot.
99%. They explain plasma as particles with charges. Technically, it's a gas that has more than 5% ions. Ions mean charges. It can conduct electricity, which a gas can't do. Stars, space, and fluorescent lamps use that. The sun is made of plasma that's about 6,000 degrees Celsius. There's some plasma trivia for you that I don't know if we need it or not. Nuclear fusion, where could you find nuclear fusion in the universe? It's on the sun. So sun is doing nuclear fusion. Supernova, some details that were in the book. If you picked them up, great. If not, here's an explanation of supernovas. Eventually stars run out of hydrogen. And then the helium that's left just collapses under the gravity force and you get a super high temperature, you get a bunch of energy released. That's what a supernova is about. Neutron star is what you come out of at the end of that process, and it's said that that's 10 to the 14th times the density of the sun. The sun, FYI, is already super dense. So if we go, what's 10 to the 12th power in like word numbers? Like 1,000 million. Where are we if we get 10 to the 12?
Quadrillion?
We're short of quadrillion. Trillion is correct. So million is 6, billion is 9, trillion is 12 zeros. 10 to the 12th is a trillion. So that's 100 trillion times the density of the sun is what a neutron star is. Then if we get even more dense than that, that's black holes. So here's some black hole information from the book. It said that they crush themselves. It said they leave a gravitational field. Excuse me. It's so water break. It's so dense that light can't even escape it. So how they detect those is you have to see the effect on the objects that pass by them, like something's going by and like changes direction. Must be a black hole. Conductors, I have a note, side note here, conductors have some resistance to electron flow due to vibration. If Imagine walking down the hallway right now. You'd be good. Imagine walking down the hallway in about 4 minutes when the bell rings. There's people in your way. If you get vibrating particles through some sort of metal, it's the same kind of idea. Electricity wants to flow. If there's a bunch of vibrating stuff in your way, it's going to slow you down. That's kind of like what resistance means. So conductors have some resistance to electron flow. What's going to happen to motion at absolute zero? Everything stops. There is no motion. So if you get to absolute zero, there's a thing called superconductivity, which means there's no resistance to electron flow. You would just flow down the hallway as just described. Why don't electric companies generate superconductors to give you your electricity then?
That'd be kind of hard to do.
It'd be kind of hard to do because you have to get it to
It's like
absolute zero. But there is a question in the chapter review: are electric companies happier in the winter or summer?
probably winter.
Winter, because it's
Yes.
colder and you get more or less resistance on their wires.
Left.
Less, because it's colder. So they're going to do better there. Kinetic theory, I already gave you the breakdown on that. Inference process, I've got no other notes. Question about anything I'm talking about there? So next quiz, you have it. I think it's out of 50. Basically, everything today from 11 down stayed the same, but the top part got reworked around a little bit. The other thing cooking is a chapter review. So chapter review, there's 12 questions, there's 7 problems. I was just peeking at the problems. If your book is handy, join me on 212. If it's not, then don't. But one of the questions involves a graph on 212. So it's just basic graph reading skills. There's this like blue line, and then there's an x-axis measuring boiling point and a y-axis measuring pressure. So they could ask you questions to read this graph by looking at the blue line. So let's say I tell you the boiling point is 80. Can somebody guesstimate me if the boiling point is 80, what the pressure must be?
0.5.
0.5 if we're looking at the decimals, or if we're looking at the whole numbers,
50.
50. How did you do that?
I looked at where it,
Yeah, I said 80 and you just tracked up till you hit the blue, and then to find the matching number you tracked left and like guesstimated it. They could work that in reverse, like if I said pressure is 80, if pressure is 80, guesstimate the boiling point now.
95.
95 maybe, 93, something like that. So there's one of the problems in the chapter review does that. Another problem in the chapter review just breaks out E equals MC squared. So follow that. Another one breaks out some stuff about watts. So you might have to look up, what was watts a measurement of?
Electricity.
Power? What was the equation for power equals?
Work over time.
Work over time. So you might have to dive into something like that. There's also some questions that are just sort of like basic math. You just need to like multiply stuff, but the questions are a little funny. But if you have questions about it, I'll field those next time, because that's all we have for this time. So stop that, and then let me grab your scores before you run.